I'm Zuber-Skerritt, the producer of a series of video programs on postgraduate research, supervision and training. This video series has been produced simply from recordings of a residential staff development program on postgraduate supervision for women held at the Twin Waters Resort on the Sunshine Coast of Queensland in April 1992. The aim of this series is to provide supervisors and postgraduate students with resources to understand and improve postgraduate studies in their department or institution.
My basic philosophy, I think, is fairly similar to the philosophy that's been expressed by quite a number of other people, and that is to look at the whole writing exercise as part of the overall candidature, not just to look at it as a bit that comes at the end, but that something that really starts right at the very outset. And I'd like to think that when a candidate comes to finally prepare the thesis ready for submission, that a lot of the trauma has actually gone out of the task, because if there's a very clear definition of these things on behalf of the supervisor and candidate, the theoretical basis of the study is sound, the design of the experiments is impeccable, the analytical work that's to be carried out, the way in which the questions that have been posed are to be answered, those analytical methods have been carefully conceived or tested. Statistical techniques are appropriate. If those things are all quite clear, then a lot of the problems will be solved. Some of the answers to those things can be found in referees' reports in papers that are subsequently published, and that's part also of my very strong message, and it's one that other people have expressed. That is that people should, in the sciences at least I believe, be encouraged very actively to publish material as they go along. There's a vast number of advantages in that, and some of them are listed down here. If they do prepare material and submit it for publication as they go along, then the results will have been analysed by them and together with their supervisor, and they will know precisely what they mean. They won't be confronted at the end with a great undifferentiated, unanalysed mass of data that are daunting in the very extreme. They will have divided up into parcels. Each of those parcels will be analysed and they'll know what it means. And the relationship between those data and the general field will have been established and discussed, and then that will have been through the sieve of or the screen, or sometimes perhaps the screams of referees, and the referees will have been able to give feedback to the candidate about the different parts of their material, and so there will be a lot more confidence on the part of the candidate that the material will stand up to the scrutiny of the examiners, and confidence on the part of the supervisor as well. So I think that the best way in my experience, and I accept there's other ways, the best way in my experience is to ensure that those things that are written in red are impeccable. That's not part of my talk today. That a series of skills relating to the scientific literature are acquired. These are the ones that I've put down in green, and I'll talk about those in a little more detail. They're understanding the scientific literature, searching the scientific literature, and analysing papers. I won't really talk about analysing papers in detail, but those skills must be acquired, and I'll talk a little bit about how I think they can be acquired, but not the third one in detail. And then having got a clear understanding of the literature and the way in which one might go about approaching the writing of a scientific paper, then I believe that the candidates at regular intervals throughout their candidature should be given practice in the writing of their own material, writing for publication in scientific articles, writing for presentation at conferences, but a lot of writing so that they get the skills of writing, they analyse their material, they get feedback from referees and also for people at conferences. So my first message, which I feel very strongly about, is that the process should start right at the beginning of the candidature, process of writing right at the beginning of the candidature, and indeed in some cases I'd hope it would have started beforehand. Scientific literature. What do the candidates need to know about the scientific literature? I should say, in relation to that, what sources of information are there available to us as supervisors to trigger our own memories of what we believe is important, but also to get another person's point of view. And I'll put on at the end of this overhead a series of overheads about references to publications that I think and somebody else thinks are particularly valuable in this area. They're also set out in that handout, but the key ones, because I realised the last minute that the handouts wouldn't go all the way, are key ones I put down on overhead. But I think it's important to ensure that students know these things that are in green. How can they acquire those skills? I suggest that the best way of acquiring these particular skills, and I'll go through them a bit, is to have them presented in a discussion, a tutorial. The term lecture is probably a bit unacceptable here, but at least the students should be presented with somebody's point of view about a whole lot of aspects of the structure of the scientific literature and how it works. Such questions as, what is the role of scientific papers? Now, I don't claim to have the fountain of all wisdom about that sort of thing, but certainly one of the key roles is the transmission of information between scientists and users of science. Also, in some places, unfortunately, they're used for other purposes, and one has to bear that in mind, things like allocation of Bickies. But as far as the students are concerned, I think the key role of transmitting information between scientists and the users of science is something that really must be brought home to them. And following directly from that, what are the features of a scientific paper? Scientific paper is the primary unit of the scientific literature for those who aren't so familiar with it, and for anything to be regarded as part of what you might call the fabric of science, to use a fairly grandiose term, has to, I believe, have been published in scientific papers, ones that fulfill these criteria, and have been through the screen of critical referees. These papers should be original, that is, the material should not have been published elsewhere. Some presented in conference papers perhaps, but that should be clarified. The material must not have been published elsewhere. It must be presented in a form in which it's able to be assessed and evaluated by the reader, and it also must be in an accessible form. That business of accessibility becomes a little bit more of a problem as time goes by with some electronic storing and transmission devices which aren't so readily accessible to some people, and also with some commercial contracts that people have to engage in for economic reasons. But generally, the material must be accessible to readers in general, even if through interlibrary loans or other things. What's the structure of papers? What's the structure of an introduction? We had a good session on that with Peggy earlier on, basically to fill in the background in the field, to introduce the most relevant literature, and to lead in a very precise way to a statement of the questions that were asked in that paper. These things I believe we should present to our students, and present them quite unambiguously. A statement of materials and methods, giving in sufficient detail that they can be at least understood clearly the key points of the analytical methods, and preferably details. Sometimes editors won't accept a large amount of detail in materials and methods, but basically it should be quite clear how the author set out to answer those questions. That should be stated in materials and methods. Results pretty straightforward, but there are some conventions that those of us who are involved with this science business know about, that students should be aware about. That the results section should include all of the relevant results. You can't, by convention, introduce a few bits of new results in the discussion, and you can't have any bits of discussion in the results section. Those sort of things really have to be brought home to the students, otherwise they learn by bitter experience. And then a discussion with a brief restatement of what the key points that key answers, if you like, to the original questions were and how they fit in relation to the general structure of that subject. That material, I believe, can be well presented in a discussion with students. I actually do something very similar to that to third-year veterinary students on the grounds that they, although they may not be doing scientific research later on, a lot of them are writing papers of one other sort or another, and they're also reading them and analysing them. Important for them to realise what's the role of referees, that in fact with the decent journals the material is sent out, papers are sent out to referees, the role of the referees to really determine the worth of the paper without going into that in great detail, and the role of the editor to predigest a bit the comments of the referees and to come to a conclusion on behalf of the journal about the fate of that paper as far as the journal is concerned. That's then transmitted back, of course, to the authors, and they then can do with it what they will. But I'll talk some more about that in a little while. As I said, those things I think discussed in a discussion session. Also the role of secondary sources. These scientific papers are the primary sources. The secondary sources such as reviews and monographs, what's their role? Mainly the point that I try and get across very strongly is the necessity for students, candidates, to go back and check the original paper if they need some key information. Don't just take the author of the review, don't take their word for it, because often it's biased and sometimes wrong. Go back and check the original information. Tremendously important. I'll go down to the one at the bottom in red. That's why I put in red. Critically important. How to assess the scientific worth of papers. That's another set of skills that the students must acquire. It's not so much tied up with this exercise of writing, and that's one of the reasons why I'll speak very briefly about it. But I believe that we should encourage students throughout their candidature and also their undergraduate stages to critically question the material that's presented in the papers, in these scientific papers. Question the aims of the paper, that is the questions that the author set out to answer in the beginning. Question the materials and the methods that they use and the statistical design and the analytical methods, all of that, to question it to the best of their ability, which of course they may have deficiencies in terms of their own training, but to do a critical and analytical job, not to take it at face value. And the same with the results section. Are the results credible in terms of the way in which the design was planned and carried out, and are the conclusions supported by the results? Are there any alternative conclusions? Are there any bias in the conclusions? Those sort of things. I think that those skills there can be taught in a discussion session as well, but they need to get a lot of practice in those skills, and I believe that in good departments they get this practice in what are usually referred to as journal clubs, where a group of them with staff members sit around and critically analyse papers on a fairly regular basis. Another set of skills that they must acquire are the ones in using the abstracting and indexing tools of the library. I left that till last because that's something that I always leave to somebody else, that is the staff in our library. As I said at the outset, my very strong belief is that students should be encouraged to write material as they go along. The question is, how do I encourage them to do that? I have them acquire the skills through the group discussions I've just described. I've just described the beginning of it, but I also have them in a group discussion session go through, with a fair amount of direction, steps in the writing of a scientific paper. Now, Peggy earlier on talked about modelling of behaviour. The only way I know about how to teach this is to tell people how I do it. I don't claim it's the right way, but to some extent there's probably no other order than what I'm talking about here. But there are some big decisions that have to be made, and I talk to the students in a little bit of detail about the criteria that I use in relation to each of those points. The first one, how does one go about selecting a journal? That's something that we could talk about here for quite a long time, and I'm really sad that we can't. I can simply say that what I do is try to pick out the most prestigious journal that's likely to publish it. Now, you get a bit of a feel for whether you can pitch it at that level or that level, but also there's the matter of field, whether it's right within their field, and they're getting pretty specific these days. But that's my general criterion, the most prestigious journal that's likely to publish it. But a big question comes up of the extent to which a supervisor will be part of the list of authors in a scientific publication. I believe that in general they should be, but they should be certainly not first. The way in which most of these projects are undertaken, it seems to me, by a progressive, by the student becoming progressively independent of the supervisor, and at the outset the supervisor may in fact contribute a very substantial amount to the whole conception and execution of the project, or supervisor and staff. But progressively as the student goes on, of course, they become more and more independent, and there may become a point at which the supervisor can no longer justify being a co-author on the papers, but certainly at the outset they should. Well, it's appropriate for them to be. The argument may have to be made. The next step is simply organising the material. You've decided on a journal, decided on who's going to be the authors. Organise the material, just get it together to make sure that it's complete. Very often I find that when I get to that stage, I see, oh, there's a little gap there, we've got to go and do a couple of extra experiments and fill in a couple of gaps. And then determine the precise form of that the paper will take. I believe in doing that pretty early on in the piece because it does depend on the journal requirements. The journal requirements are now fairly standard requirements for different journals, but I believe that it's essential, and I believe students should be encouraged to do it, to get a copy of the instructions to contributors for that particular journal and follow it from the outset. Decide on the order of the writing's going to be done. I have a simplistic view about that too. I always start with the part that's easiest. I find that the easiest part is almost always the materials and methods, because you know what you did, so you just write all that down, and then you get into the swing of it and you say, oh yes, well I got these results, and so I go on like that. And then the discussion seems to me to come logically next, and then the introduction, because some people argue very strongly that you should go through and do this step as quickly as possible to get a complete draft on your word processor, as most people do it these days, as quickly as possible, and I agree with that. The title's pretty important. I think it's, considering the title probably comes in about this stage, and then to refine it comes in later on. The title of such critical importance in terms of indexing and abstracting, and also in attracting readers who happen to be scanning through lists of articles. So that it's absolutely vital that all of the key words that relate to the article be included in the title to the extent possible, but they also make some logical sense in the way in which they're organised. But I think that at that sort of stage it's worthwhile considering it, but considering in those terms what do each of these words mean, and what's their importance, and then come back to it later. Then I think you've done all that, well, that's the students done all that, and I tell them, well, I think at that stage it's best to put it away. Put it away for a day or a week, not for a month, because you might never get back to it. But I'm a great believer in subliminal processing, and I find that when I come back to it, things are always a lot clearer, and relationships that weren't apparent for a start may become apparent. And then rewriting it, concentrating on firstly the structure and also the style. Those two are pretty closely related in lots of ways. These are the points that I ask my students to consider. I go through in a sort of a tutorial type session and so on. I believe these are the things that one should talk about, should really give attention to in the rewriting process. The structure and the style. Very much interrelated, and whether one calls something style or structure doesn't matter. But a key point, and Peggy made that in a very good way with that introduction, concentrate on the logical presentation of the ideas. Make sure that the idea in one sentence flows onto the next sentence, one paragraph flows into the next paragraph, and so on. But also then, apart from that, and sort of superimposed on it in a way, ask in a very rigorous way. I try to get these people to be as rigorous as I possibly can in relation to things like, ruthlessness about whether the material in that sentence or that word or whatever is necessary. Does it contribute in any material way to the story that's being told? If not, get it out. Is it correct? It should be correct after all you've written it down. But sometimes I at least, and lots of other people, find that something they've written down isn't really correct. Is it in the best place? That's tied up obviously with logical presentation, but you might say, well, it looks okay here, but perhaps it might be better way back there. Again, look at the title. See whether the title that you've got is an accurate representation of what the material is. Figures and tables. I think they should have been drafted out, and I didn't mention this, drafted out at the first draft stage, but very important, I believe, to make sure that they illustrate the points that are made in the results, but don't contain any redundant information. Some people say, oh, really, that bit of information, that really should be there somewhere, but they don't have it in the results section itself, just have it in a figure. Forget it. That's not a good argument. The figure should be, with its caption and table, should be able to be understood without reference to the text and vice versa, a point that's a bit hard for people to really grasp. But the figure and table should illustrate the points made, should be able to, the reader should be able to read the text and say, now what's the evidence for that? Go to the illustrative material and say, this is the evidence for it. And it should stand alone in that sense, I believe. Check in detail for clarity and completeness. With these things, that's title, figures and tables, but also for the whole lot of the rest. Style. This is where we really get into the difficult part. The points that I tell my students about is, firstly, try very hard to write clearly. In relation to each bit, say, is this clear? Can it be understood? Can somebody else understand it? Really more important. And knowing exactly what you mean. I think it was Peggy who alluded to this earlier on. The very fact of writing something down usually clarifies it in our minds. I use a quote from a fellow called Wallace who said or wrote, "How can I know what I think until I see what I say?" And that appeals to me because it's the way in which I work. I tell them to be as precise. That's the message that editor was getting across. To be as precise as possible. To use words in their exact meaning. If they don't know the meaning of word, look it up. If they're still in trouble, find another one. To avoid imprecise words, the words that really don't have any sort of quantitative meaning. The ones that I think of are things like substantially and very much more. All of those words that what do they really mean when you get down to quantitative terms? Try and keep the sentences short. I can't read long sentences, so I'd have to tell people that. Avoid these complex modifiers. That's one of my really great problems. I simply cannot understand some of these great long lists of modifying words. I have a couple of examples which I can't remember, so I have to look at them. These are from my field, of course. Serious brucellosis eradication program problem. Now that's real came from somewhere. Or an abnormal serum enzyme liver function test result. Which word really relates to which one? The problem is, it seems to me, that very often in an effort to be concise, people put all these words together, but they've overdone it and the meaning becomes very much clouded. Use simple language. I got into trouble a little while ago for using a long word before I started, but I usually try very hard to use simple language, but not all of our colleagues do. In the literature that I'm mostly involved with, which is veterinary anatomy, physiological type literature, the students have learnt a lot of new words over the previous not very many years, and they really want to show everybody that they're smart by using them. I say forget it. Use simple language. Avoid these pompous expressions that some of our colleagues like to use, the politicians mostly, not so much scientists. at the current point in time, those sort of ones. Try to get rid of those, and try and get rid of jargon. Jargon's, somebody yesterday used the term appropriate words and not jargon, and sometimes it's very hard, I find, to get the message to students just what's the line of separation between appropriate language in the area and jargon, and it's so area specific that it's a bit hard to give many good examples of it. Be concise. That's a message that I've been getting across all the time. Watch the tenses. Tenses are one of those really difficult things. Journals often have a standard policy in relation to tenses, at least the ones that I operate in, putting, for example, all of the experimental results in the past tense, and then when relating them to the general state of knowledge, the present tense may be appropriate, but whatever, I try and encourage them to be consistent. So they've rewritten this paper, or they've been told to rewrite it, with taking note of those things. Then to seek feedback from from experts, such as their supervisor, and non-experts who can look at it, perhaps non-experts but intelligent lay people, who can look at it and say, yes, this really doesn't make such a lot of sense. Recheck the details, including references I put there in yellow, because that was something I just occurred to me later. So very often people are confused about this, young people who aren't experienced, are confused about this business of references until they get the story straight. The story is that you can only put the papers that are actually cited in the text in your reference list, and the reference list should contain all of those, but no more. They should also be accurate. That's a bit hard, although now people seem to be getting these computer programs that do all that for them. So, but recheck all the details. I find that not uncommonly some of the details get a bit mangled, or descriptive details get a little bit mangled as you go through some of these rewriting stages, and it's very important, I think, to go back and make sure they're right. Then rewrite it, making sure that the whole story then is consistent. By this stage they should have something that's really consistent, following the journal requirements, and then this will be, as they say, I think, in some of these quarters, an iterative process, and finally on the word processor will come up something that looks pretty much ready to go off. Check it and check it and check it again. Send it off. Send it off to the journal. Make sure you've followed precisely their requirements. Some want 3 copies and all that stuff. Keep an exact copy. Learn from the editor's response. Then at that stage, the paper will say it's been accepted. It may at that stage be necessary to write an abstract, and I tell the students about, that some papers have abstracts in them, some just have summaries, but at some stage it is certainly necessary to write an abstract, even if only for biological abstracts, and the structure of an abstract, that it should have a clear statement of aims. Not all of them do it. A clear statement of the questions that were asked, how the author sought to answer them, what results were obtained, and what they mean, all in a very concise form. And I also make the point about proofs. What I think happens is that a spelling checkers put through the thing, they find an error, and then the spelling checker comes up with alternatives, and they press a button and put in that alternative. Because sometimes, even with fairly long words, I've seen a totally wrong word put in the text. Now, it looks as if it makes sense, but it's not until you go through and look at it word by word that you can see that they've made a blue. So that's the sort of stuff that I present in a seminar-type session for the students. Later on, when they've got their own material, they should be encouraged, I believe, to follow these steps, progressively refining their writing skills with the aid of their supervisor. Then converting that to a thesis. They've got a series of papers, not all of it perhaps, the thesis material written up in papers, but a lot of it, I'd like to think. If they've got that done, then the whole task of preparing the thesis is much more manageable. Make sure that the introduction is up to date. Somebody made that point before. Make sure that it's a review of the literature that leads directly into a statement of aims and questions, that there's a single materials and methods section for those methods that are common to the various results chapters. The various results chapters may then have specific methods and specific experimental designs for those experiments. That the results chapters form a logical and non-repetitive sequence, that the discussion provides a critical overview of the place of this work in the overall field. and the thesis should then become a single, cohesive, internally consistent, well-argued, all those good things, document which contributes in a substantial way to knowledge. The role of the supervisor in all that, I believe, is, and I would say it very quickly, to plan out, help planning out the time, because students always believe that it's going to take a lot less time than it in fact does. The SERC document has something about that, but as Peggy, I think, said, they seem to be starting from the premise that people haven't written it up in advance. The supervisor should do all these supportive things, I think, should be available. One thing that supervisors are often not is available when they're needed. Should be supportive and sympathetic and, above all, patient, but while being patient should be appropriately firm to make sure that the process doesn't drag on too long, and at the same time be constructive, with emphasis on the constructively critical of the work, and to ensure that to the extent possible the thesis is logical and well argued and sound, requirements have been followed, the final copy is in fact ready for submission, and that the candidate isn't so sick of the thing that they put it in a form that's flawed, and but that be done without too much delay. That is, the student doesn't go the other way and try to get absolute perfection. Should be pretty close to perfection, but there's a view about what represents perfection, and it's not one that's uniformly shared, especially by students and supervisors at the last stage of the process.